Inheritance allows you to have a class that is derived from another class, which also is referred to as parent-child classes, where the parent is the base class that you derive from. The child class will inherit the public and protected methods, constants, and properties, which then can be overridden. In addition to inheriting these in the child class, you could of course also have additional properties, constants, and methods. We're going to cover a few examples here. The first example I'm going to show you in actual code, and the other examples I'm going to show you some diagrams and go over some of the use cases for the inheritance, and then we'll also talk about when you should and should not use inheritance. So make sure to watch this video till the end. For the first example, let's use something very simple to understand. Let's say that we were implementing a toaster simulator that can toast bread. Here I have a toaster class that has two public properties. One of them is the slices that stores the slices to be toasted, and then the other property is the size, which indicates the maximum number of slices that this toaster can toast at the same time. Then we have the add slice method, which simply adds the slice to the slices array, and it only does that if we haven't reached the maximum number of slices. And finally we have the toast method, which simply loops through the slices array and prints toasting slice to the screen. You might be asking why I didn't use the constant here, because the size doesn't really change during the runtime, right? This toaster can only toast two slices at the same time, so it makes sense to have this as the constant. The reason for that is because I want to cover overwriting constants and statics in a separate video once we get to the late static binding topic. So this is okay for now. So let's test this out. On the index.php, I'm creating the object of the toaster class, and I'm adding a slice of bread, and then I'm calling toast method. Let's open the terminal and let's run php public index.php, and we see that it's toasting one slice of bread. Now let's add a couple more slices here and let's run it again. And as you can see, it's only toasting two slices, even though we have added three slices here, because the maximum number of slices this toaster can toast is 2. The ideal way would be to throw an exception here if we reach the maximum number of slices, but because we haven't covered the exceptions yet, I decided to keep this simple and do it this way. So let's say that later we want to implement a simulator for another more advanced toaster that has a bit more functionality and more features, and let's say that it's the pro version of the original toaster. Instead of toasting only 2 slices of bread at the same time, the pro version can toast 4 slices at the same time, and in addition to having the basic toasting abilities, it also has the preset to toast it as the bagel. So let's create that class. I'm going to duplicate the toaster class and create toaster pro, and let's split the view here and let's change this to toaster pro, and we need to change the size to 4 because this can toast 4 slices at the same time. And we also need to add a method here that toasts with the option of toasting it as bagels. So we could do the same thing as the toast method, but we could add wording here that is toasting with bagels option. Alright, so right away we can see the common functionality here, right? We have the add slice method, which is exactly same as the toaster add slice method, and we have the toast method, which is exactly the same as the toast method here. And that's because the toaster pro is also the toaster, right? And notice the relationship here. Toaster pro is a toaster, which means that it can toast bread with the regular basic settings, but it could also toast bread as the bagel settings, and it can toast 4 slices at the same time instead of 2. So because of this, we can leverage the power of inheritance and inherit the toaster class in our toaster pro, and we can do that by using the extends keyword. So we could do extends toaster, and now toaster pro inherits all the public and protected methods, properties, and constants of the toaster class. That means that we can get rid of the slices property, we can also get rid of the add slice method and the toast method, and we're just left with the toast bagel method. As mentioned before, you're able to overwrite public and protected properties, constants, and methods, and that is exactly what we're doing here. We're overwriting the size property with the value of 4 because toaster pro can toast 4 slices at the same time while the toaster can only do 2. So if I go to the index.php and open the terminal, this can only toast 2 slices, right? But if I change this to toaster pro and let's import that and run it again, we see that now it's toasting 3 slices. I can add a couple more slices here and we see that maximum number of slices is 4 because that's what we have it set here. Now, in addition to toasting it as regular bread, we could also toast it as bagel, right? So we can call toast bagel and we run it and we see that it's toasting bread with bagels option. Also, something worth noting is that if you remember the definition definition of the variable this from one of the previous lessons, the this variable refers to the calling object. In this case, when we access the properties or methods using the this variable, it does not necessarily mean that it is accessing those properties on the parent class. It can be accessing them on the child class. Let's var dump this variable in the parent class and see what we get. As you can see, this variable refers to the Toaster Pro class because that is the calling object. If we go back to the index.php, we are instantiating the Toaster Pro here, and we're calling the method from the Toaster class because Toaster Pro inherits or extends Toaster class, which is why the this variable in the parent or the Toaster class is referring to the Toaster Pro instance. Now that we know the basics of inheritance, let's talk about some of the other important details. If we set the size property to private and we run the code, we see that now it's toasting only 2 slices even though we specified 4 here. That's because you cannot override private properties, because private properties belong and exist only in that class, right? Even the class that extends the Toaster class cannot access private properties. You can only access and override public and protected properties, methods, and constants. Another rule is that you cannot decrease the visibility of the properties. So if you set size to public, you cannot decrease the visibility of the size, so you cannot set this to private. It's going to give you an error and it's underlining it. If I run it, I'm going to get that error. You cannot also set it to protected because protected is lower than public and you're essentially decreasing the visibility and it's not going to work. On the other hand, if you set this to protected, you could override it either with protected, which in this case would work. So if I run it, everything works, or I could do public and this will still work. The same exact rules apply to methods and static properties and methods and constants as well. As you know, public properties are not ideal because they kind of break the encapsulation, right? In this case, the size property is set to protected in the parent class, but we are overriding it with the public visibility, which means we're increasing the visibility in the Toaster Pro, and essentially we can do something like this. We can do toaster size equals to 10, and now we have set the size to 10 explicitly, and even though this toaster can only toast 4 slices at the same time, we have changed that, and if I add more slices here and I run it, we're able to toast more than 4 slices. One fix, as you know, is to set this to private, but then we cannot override properties, right? Another fix is to use the protected access modifier, which is essentially same thing as private, but it extends to the child classes. So let's set everything to protected, and now if I run it, we're going to get this error that we're no longer able to access the size property. So let's talk about method overriding. I'll show you an example of overriding constructors first, and then I'll show you an example of overriding other methods. As you noticed, we don't have any constructors in the Toaster or the Toaster Pro class, and that's because constructors are not required. Let's add the constructor method to the Toaster class here, and instead of initializing the size property to 2 here, we can simply do that in the constructor this way and remove the initialization from here, and let's do the same thing for the slices, and we could do the same thing here. Let's do public function construct, and we could simply overwrite the size property to 4, and because size is set to protected, we're able to access that property, and we could remove this property overriding. Now if I run this again, we're getting this strange error that says that slices array must not be accessed before initialization. So what's happening here? Let's go to the index.php line 10 and let's debug this. So on the line 10, we're calling add slice bread. So let's go to add slice, and add slice is within the Toaster class, and what this is doing is that it's accessing the slices property, which is right here, but it's saying that this property is not initialized, but we have initialized it in this constructor here. So why it's not working? The reason this doesn't work is that when you override the constructor here, by default it's not going to call the parent's constructor method. So if I comment this out, the overriding part, and I run it again, everything is working, no more errors. But when I override the constructor method, or any method in that sense, it is not going to call the parent method by default. So if I run it again, we get that error. You need to explicitly call the parent method using the parent keyword, then double colon, which is the scope resolution operator, and then call the construct this way. Now if I run it again, everything is still working. Something to note here is that you need to be careful when you call the parent construct method. If I were to call this method after I overwrite the size property, so if I call it after right here, this is going to cause issues because we are setting the size property to 4 and then we're calling the parent construct, which in here it sets the size property to 2. So essentially it will reset the size property to 2. If I run the code, we see that now it's only toasting 2 because the size is now set to 2. So just be careful when you call the parent construct method. I personally always put it on top unless I have some special logic where I need to do some stuff before calling the parent construct, like maybe prepare arguments that need to be passed into the parent constructor and so on. So if I run this again, everything is back to normal. Another thing to note is that if you don't have a constructor in the parent class, then you cannot call the parent construct. If I try to do that, we're going to get an error that there is no constructor in the toaster class. So I would need to comment that out as well. And this is perfectly valid. You don't have to have a constructor in the parent class in order to have a constructor in the child class. And because we are not initializing the slices array, we need to initialize that to avoid getting errors. So let's set that temporarily. If I run it, everything is back to normal. I know there is a lot to take in here, but don't worry about it. Watch this video as many times as you want, and also it will come with practice. You don't need to memorize any of these things. As you're coding, you'll get those errors and you'll be able to fix them whenever they come up. So don't worry about this too much. So let's change this back and let's continue. The same applies to other methods than the constructor method. So let's say that we wanted to override the add slice method, which accepts the slice as an argument. If we don't call the parent add slice method explicitly, it's not going to do that for us automatically. So if I run this again, we see that nothing is being printed. And that's again because it's not calling the parent method automatically. We need to explicitly call that by using parent add slice and pass any necessary arguments, which is slice in this case. And if we run it again, everything is still working. Now you could add the custom logic to before calling the parent method or after, but this is not required. You don't need to call the parent method. If you want to override the method and have custom logic in your child class, you can do that, and you could do custom logic here. In this case, it's not going to call the parent method at all. When overriding a method in PHP, the method signature of the child class must be compatible with the signature of the parent method. Otherwise, you'll get a fatal error, or if you're on a PHP version prior to PHP 8, then you'll just get a warning. For example, in the add slice, we're expecting string slice, right? If we change this to something like integer slice, this is not going to work. If I run the code, you see that we're getting the fatal error. Same applies to the return types. So if I change this back to string, and let's say we change the return type to an integer, this is going to result in a fatal error as well, because the method signature is not compatible with the parent method signature. There are things like covariance and contvariance that make parameter and return types a bit flexible when it comes to inheritance, but don't worry about that for now. We'll cover those in a separate video. The compatibility rules do not apply to constructors. So let me remove this from here, and let's accept some kind of parameter in the child constructor. So we could do something like string x. So as you can see, the method signature of the child class is not the same as the method signature of the parent class, but because this is a constructor, this is okay. The signature rules do not apply to the constructor methods. It could also accept different types of arguments in the parent constructor. So we could accept something like int x, and then we accept string y here, for example, and maybe we accept int z. And then the only thing you need to do is you need to make sure that you're passing the proper arguments to the parent constructor call if you're calling the parent construct. If you're not calling this, then you don't need to worry about it. But if you're calling the parent construct, then you need to pass the proper argument. Now that is up to you how you want to pass this. You could still accept the string x as the first argument here and pass that down and just accept additional 2 arguments in the child class, or you could simply hardcode this to something and don't accept it as the argument. But it's basically up to you how you want to handle it, depending on your application logic and requirements. All right, let's remove this from here and let's continue. You could also have different names for method parameters, which won't cause the compatibility issues, but they can cause errors if the named arguments feature is used. So again, if we were overriding add slice method here and we call this something like slice x and pass that in, this is perfectly valid. It will still work. If I run the index.php, we see that everything is working. But if we were using named arguments here, we see that this is not going to work. If I I run it again, we get an error that is an unknown named parameter slice. So because of this, since the named arguments feature was introduced, it's better to match the parameter name. So we would change this to slice and everything would work. What if you want to make sure that a specific class or a method can be extended from? In that case, you could use a final keyword. If you define a class as final, so you add the final keyword before the class keyword, this makes it so that you cannot extend from this class. As you can see, my ID is underlining here and telling me that I cannot inherit or extend from a final class. So if I run this code, we're going to get the fatal error. Similar to classes being final, you could also have methods as final. So you could say that addSlice method is final, which makes it so that addSlice method cannot be overridden. So if I run this now, we're going to get a fatal error because we're trying to override a final method. If I remove this and run it, now everything is working. So basically, final keyword can be used to prevent class inheritance and method overriding. Before we move on to other examples, I want to mention that PHP does not support multiple inheritance, which means that you cannot extend more than one class. However, it supports multi-level inheritance, which can be used to achieve hierarchical inheritance. For example, if we had another premium toaster that has all the features that the Toaster Pro has, but it also has some additional features, we could extend Toaster Pro in that class, and that class would inherit all public and protected methods, properties, and constants of both Toaster Pro and Toaster classes. Alright, let's look at some other examples. Let's say that we had a transaction class where we process transactions and so on, and it has all the necessary properties and methods for that transaction to be processed. Now let's say that we also have another type of transaction, which is a refund transaction, and that could be represented as another class. Yes, you could have refund method within the transaction class, but what if you had specific logic on how you refund your transactions? In that case, refund transaction might be another class that has its own custom functionality, but it also inherits all the necessary properties and methods from the transaction class. Another example is with a payment account. You could have two types of accounts, for example. You could have a checking account and you could have a savings account. Now, because checking and savings accounts share some common functionality, you could have payment account as the base class and extend checking and savings account from them. Or you could simply just have a checking account and then extend that from the savings account. But that doesn't really make sense because savings account is not checking account. And keep that is a relationship in mind, and we'll get to that in a minute and I'll explain what that means. Next example is with the form fields. So think of it as the tree structure. We have a base field which has some maybe properties and some methods that apply to the basic field. And then we extend that base field into text fields, into text area fields, into Boolean type fields, and so on. Then each individual of those type fields can extend further, and we can have email text field, we could have number text field, or we could have date and time text field, right? They're still text fields, but they have some additional functionality to them. Then we could also extend further the number field into the % and dollar fields, which are also just the number fields, but they have some additional functionality to them. And the same applies to the other types of fields. So as you can see, this is an example of multi-level inheritance. Instead of inheriting from one class, you're inheriting from multiple classes through a hierarchy. So it's not multiple inheritance, but it's inheritance through hierarchy, which means that the dollar field here inherits everything from the number field, and then it also inherits everything from the text field, and it also inherits everything from the base field. So this sums up with the examples. We'll get to more real use cases and more real examples later in the course once we actually work on the project, but let's talk about why inheritance might not be a good idea. So inheritance is good in general because it's part of the object-oriented principles, right? But it can also be bad when it's misused or if it's overused. For example, inheritance could break the encapsulation because it has access to all the protected and public properties, methods, and constants of the parent class. So for example, in this case, I am directly able to change the properties of the parent class, and this might be okay because this is by design, but it could also break the encapsulation where you're allowed to do this. You could do this in any other method, right? You can change the property size to 999 and so on. Another downside of inheritance is that when you're inheriting from parent class, you're actually inheriting all the public and protected methods that you might not even need in that child class. For example, let's say that the toaster class here had some kind of additional method method that did not apply to the Toaster Pro. Maybe it was deprecated later, or maybe the Toaster Pro no longer needed that method, but the basic toaster class had that method. Let's call this method foo for now. And let's say we were doing something specific to the basic toaster class. Now, when we extend toaster into the Toaster Pro, this Toaster Pro has access to this foo method. And when we instantiate the Toaster Pro here, we're able to call that foo method. And that might not be ideal because this method might not apply to Toaster Pro at all, and you might not want to allow calling of that function on the Toaster Pro. The typical solution to that you might see in some code bases is to override that method and simply throw an exception. And this, in my opinion, is not a good design. So if you see yourself doing inheritance that way, where you're forced to override a method and throw an exception this way, try reconsidering using inheritance in that case. You might want to reach for something else like composition, for example. And we'll talk about that in more detail later in the course once we get to the inheritance versus composition topic. One thing that I missed to talk about is how you would actually type hint an object of either Toaster or Toaster Pro when accepting that as an argument into another function or a method. So if I go to index.php, I'm just going to demonstrate this by having a custom function here and not a method. So I'm going to do function foo, and let's say that we're accepting Toaster Pro and call that Toaster Pro. And let's simply call Toaster Pro toast. Now we can call that method here and pass toaster as an argument, and let's remove that, and that will work. Now, what if we passed in a toaster instead of Toaster Pro? This is going to result in an error because toaster is not a Toaster Pro. Toaster does not extend Toaster Pro. Instead, Toaster Pro extends the toaster class. So Toaster Pro is a toaster, but toaster itself is not a Toaster Pro. The way you can fix this is that you could simply type hint the base class, which is the toaster, and let's change that to toaster. And the toast method is available on both Toaster and Toaster Pro. And this will work, and it will also work if we were to pass in Toaster Pro. So if I run it again, now it's toasting 4 slices. There is one problem though. If you try to call toast bagel, this is going to work if you pass in Toaster Pro object, but it's not going to work if you pass in a regular toaster because toast bagel does not exist. In those cases, you might see in some code bases where they check if the method toast bagel exists, or if the object is instance of Toaster Pro, then call that method. Otherwise call the regular base toast method. But that, in my opinion, is bad design, and there is better ways of doing it by using something called composition, and we'll get to that later in this course. I mentioned is a relationship before, right? That the Toaster Pro is essentially a toaster, and you can use that relationship to decide if you actually need inheritance or not. If you have a class that you could apply is a relationship to, then you could leverage the power of inheritance. In our case, Toaster Pro is a toaster, that's why inheritance could work. If is a relationship does not make sense, or it does not apply with your class that uses inheritance, then you might be using inheritance where composition should be used instead. So my advice is to not reach for inheritance for every case. Reach for it when you have the proper is a relationship between the child and the parent. So when would you not reach for inheritance? Let's say that down the road you had to implement a simulator for one of those fancy ovens that also has the functionality to toast bread and bagels. Right? You might be tempted to implement that oven by simply extending from the toaster class, or simply extending from the Toaster Pro class to inherit all the Toaster and Toaster Pro functionality, and then add on the additional functionality that that oven supports, but that will cause more problems down the road while maintaining and adding more functionality to your application. So if you think of it another way, if oven is not a toaster and does not qualify for is a relationship, then how would we incorporate toaster into our oven class? The relationship to me sounds like oven has a toaster, or toaster is part of the oven class, right? Let's simply duplicate the Toaster Pro here, and let's name it fancy oven, and let's close this out for now. And we're not extending from anything, and let's delete all these methods. And then maybe we had some kind of method here that maybe fries things, and then we had a method here that toasts things, and then we had a method that toasts bagel, right? Now, as you remember, toast and toast bagel already exist on the Toaster Pro class. We have it right here, and the toast exists on the Toaster class. Instead of extending Toaster Pro here, we could simply use something called a composition, where Fancy Oven has a Toaster Pro functionality, and we could do that by simply using properties. So we could do private Toaster Pro toaster, and we could accept that in the constructor as a dependency. And to make this even better, we could use the property promotion here, so we could get rid of this entirely. And now we have the toaster, so instead of duplicating the toast method here, where we would copy the toast and toast bagel functionality, we could simply call this toaster toast and this toaster toast bagel. So as you can see, we did not use inheritance, but we were still able to use Toaster Pro's functionality by using something called composition. We will talk more about composition later in the course, so don't worry about it right now. I just wanted to show you an example of how to use it. This is it for this video. Thank you so much for watching. If you liked the lesson, please give it a thumbs up, share, and subscribe, and I'll see you on the next video.